Hey guys, what is up everyone? How are you people doing? Welcome back to today's session. I hope that all of you guys are doing good and taking good care of yourself. This is going to be session number 4 of magnetic effect of electric current. Today we'll be talking about the working and the working principle of electric motor. A DC motor is what we're going to talk about in today's session. So hope you guys are excited for it because I for sure am. As always, we'll start off this session also with a very interesting quote and get started with today's session. So here's the quote for you people. If you want to fly, give up everything that weighs you down. Yeah guys, that is very very true, because I'm pretty sure that all of you guys do have some friends who are not. I'm taking the examples of friends because it's something that I can relate to. There'll be a lot of people who are around you who might think less of you, who are trying to pull you down, but you have to cut loose of those people in your life and move forward if you really want to succeed. And it sounds harsh, but it's the fact of life. I hope you guys take it in the good sense, in the right sense. So with that said guys, let us get started with today's session. That is nothing but electric motor and its working. So in the last session, that is magnetic effect of electric current, session number 3, I'd given you a homework, and the homework was this people: which law can help us find the direction of force on a current carrying conductor in a magnetic field? Which law can help us find the direction of the force on a current carrying conductor in a magnetic field? And the answer to that question guys is the Fleming's left hand rule, where I told you, remember it as father, mother and the child, where the thumb indicates the direction of the force, the index finger indicates the direction of the magnetic field, and the middle finger indicates the direction of the current. So that is what is the answer for this question. I hope you guys got the right answer. Well done, all those who gave the right answer. Keep up the good work, and I want you guys to let me know what is the answer of each and every session's homework in the comment section below. All right, so with that said guys, let us get started with today's session, understanding the working and how does it what does it really depend on, and how does an electric motor work. First thing guys, you have to understand that you have electric motors all around you, from the fans that we use to the motor that is there to lift up the water from the ground up, from the from the bore wells to the tank, to the electric toothbrush that we use. All of them contain, or all of them works on this simple principle of an electric motor. So it's important to understand how does it really work. First thing guys, you have to understand that in an electric motor, the conversion of electricity, or the conversion of energy is such that the electrical energy that you supply is converted to mechanical energy. Like in the case of a simple fan, the electrical energy that you supply, you connect the socket, right? And what happens, there's a motor inside of it that converts it to a mechanical energy, and the fan starts running. And all such things that run on DC motor or electric motor in general would work on this exact same principle, where it's converting the energy from electrical energy to mechanical energy. As simple as that. Now let's look at one simple structure of an electric circuit or electric motor. So this is what it looks like on the inside. Although on the outside, when you look at it, it does not look like this at all, and I can attest to that. But then if you split open that thing, this is what you find. But this is much more the simplest structure of it. So you have battery inside of it. So the battery is generally on the outside, you don't connect it inside, so that is part of the external circuit. You have a battery, you have a set of magnets with north and the south pole, you have a coil which is also called as the armature coil, you have a split ring, you have an axle, brush, and the the fan which is connected at the end of the axle as well. So what we're going to do right now is we're going to understand all of these parts separately first. Then we'll understand what principle does it actually work on. So the first thing guys, these are the parts in an electric motor. You have magnets, coils, brushes, split ring, axle, and also an electric circuit. That is nothing but the battery which is connected to the outside of the split ring. Let's talk about that. So first thing guys, the magnets. Now, in the last session, we had talked about the left-hand rule, the Fleming's left-hand rule. And I told you this very, very clearly that when a current-carrying conductor is placed in an in a magnetic field, it experiences a force. And that is what we found out. That is what we found out using the Fleming's left-hand rule. We understood what is the direction of that force acting on that current-carrying conductor. So you have two permanent magnets which are kept on each sides. Between of that, you have the coil, which is the armature coil, which basically rotates and does nothing else. So the coil basically is actually a copper coil. So the more number of coil, the better or the more efficient the motor is. That is one more thing you have to understand. The more the number of coils that you have, the better efficient the motor is going to be. So you have a set of armature coil, which basically is made up of a conducting material like copper, and all it does is basically rotate in the clockwise direction or the anti-clockwise direction. Either one of these direction, not back and forth, but yes, either clockwise or anti-clockwise direction. And then you have the axle, which basically is the rotating part. It is the central rotating part, which is connected, which is kept in between the split rings. So these two are the split rings, so it's kept in between that. So when the split ring rotates, the axle is also made to rotate, and at the end of the axle you can have a fan, or you could have a gear, anything which you want to function, that will be connected at the end of that axle. As simple as that. And then you have the split rings. I've been talking about this for a long time now. The split rings are also generally made up of copper itself. So the split ring is also free to rotate. It is not fixed. It is also free to rotate. It is connected to the armature coil. So when the split ring rotates, the armature coil also rotates along with it. Or when the armature coil rotates, the split rings also rotate along with it. And then you have the battery. It is connected to the battery. The small black thing that you see over here, those are your they are nothing but your carbon brushes, which are generally made up of graphite. And the reason why we use graphite is because it has a higher melting point, and it's also a good conductor of electricity, and that's why you have these carbon brushes to avoid, first of all, because it has to run smoothly to not cause so much of friction, and secondly, it is also a good conductor, so we use carbon brushes, which basically is it's basically a part which connects the split ring and the external circuit. So the internal circuit, when I say internal circuit, it's nothing but the split ring, the armature coil, the split ring, the armature coil, and the magnet. All of that would be the internal circuit, which we can't see. So all of that is connected to the external circuit, which is nothing but this, through the brushes. So it basically acts like a connector between the external circuit and the internal circuit. As simple as that. And then you have the electric circuit itself, which is nothing but the set of wires which is connected to the battery, which supplies the current to that particular motor. As simple as that. So these are the different parts that is involved in a simple electric motor. Now let's talk about how does it really work. But before that, let me tell you one thing in specific. See guys, not all the parts in an electric motor actually is free to move. And not all the parts in an electric motor is fixed as well. So there are a few parts which is stationary. Those are called as the stator. Stator in the sense they're stationary, they don't move at all, like in the case of the magnet, the circuit itself, and the brushes. All of these, the carbon brushes, all of these are fixed. They don't move at all. Those are the stators. Then you have the rotors. Rotors are the ones which are free to rotate, like in the case of the coil, the axle, as well as the split ring, which are free to rotate. That is called, or those parts are called as the rotors. So you have the stators and the rotors. Now that you've understood this, guys, let's move ahead and understand the working of the DC motor. How does it really work? What is the magic behind it? Let's understand that. So here's the thing, guys. This is what a simple electric circuit of an electric motor would look like. So you have you're connected to a battery. Let's say that this is the positive terminal, this is the negative terminal. So what happens? The current starts flowing from here, gets into the brushes. From the brushes, it goes into the split ring. From the split ring, it enters into the armature coil, and then it travels all the way from here to here, from here to here, then from here to here, again gets back into the split ring, then into the brushes, and then flows straight back into the battery. So the circuit is complete, and thus the electric current is also passing through it. As simple as that. Now here's what happens. When the current is passing through this armature coil or the coil itself, there is a magnetic field. We already know that because there's a set of permanent magnets kept over here. So there's magnetic field which is going from North Pole to South Pole. This is the direction of the magnetic field. Awesome. Now, the current is passing this way. So the current carrying conductor or the charges that is passing through that conductor should experience some force. According to the Fleming's left-hand rule, we have seen that it should experience some sort of force. That is what we showed using the Fleming's left-hand rule. So that force pushes the armature or makes the armature coil to rotate. Now, how does that happen? Let's talk about that. So here's the thing, guys. The current is passing. Let's just name the split ring as X. One side of it is X and the other side as Y. And you have named the armature coil as A, B, C, and D. Very simple. And the magnet stays as it is, north and south pole. You have the brushes, which is P and Q as well. Now here's what happens. When the current is passing, when you turn on the circuit, what happens? The current passes through X, passes through A, then to B, then to C, then to D, and then back to Y, and then to Q, and then it goes back to the battery. So I'm just going to write that over here. So you have the current passing from P, from battery it goes to P, from P it enters into X, which is the split ring. From X it goes to A, then B, then C and D, A, B, C, D, then goes back into Y. From Y it goes into Q and then back to the battery. So this is the circuit, or this is the flow of current that you see in this simple circuit. Now here's what happens. Let's use the Fleming's left-hand rule, right? Now, according to Fleming's left-hand rule, when a current-carrying conductor is placed in a magnetic field, it experiences a force. So the direction of that force is denoted by the thumb. The direction of the magnetic field is denoted by your index finger, and the direction of the current is denoted by your middle finger. So let's use that over here, right? For the circuit, let's apply that to this point AB, all right, which is free to rotate. The armature coil AB, I'm going to apply the Fleming's left-hand rule. So the current is passing this way, right? The current is passing this way, which is indicated by my middle finger. The magnetic field is going from left to right, north to south pole. So what is the direction of the force on the current carrying conductor? It will be downwards. Simple. Okay, let's do the same thing for CD now. Let's do the same thing for CD. Alright, I'm going to again use the Fleming's left-hand rule. This time the current is passing towards me, out of the screen. The direction of the magnetic field is still the same, but the force this time experienced by CD is moving upwards. So this coil is supposed to move upwards. AB is supposed to go downwards, whereas CD on the other hand is supposed to go upwards. Awesome. So what happens? The coil rotates. The coil rotates because of the force experienced by the current carrying conductor. It starts to rotate. AB goes downwards, BC goes upwards. Now here's what happens, guys. When it starts rotating, at some point of time, see, the ring is actually a split ring. It's not a continuous ring. It's split in half. So there is a gap in between the rings. There is a clear gap between the rings. So what happens is that when the split rings reach that gap with that brush, when it reaches P, that is the brush P, when it reaches over there, what happens is that the current gets cut out. The current gets cut out. But then, here's what happens. Because it's already moving with the force, it completes that one rotation. Because it's already moving under the great force, what happens? It completes one rotation, and thus what happens to the armature coil is that from ABCD, it becomes DCB and A. So basically, this is what my circuit would look like. D would come over here, B would go over here, A is over here, and you have C over here. So what is happening is from A, B, C, D, the circuit basically changes to D, C, B, and A. And the split rings from X and Y becomes Y and X. Why? Because of the force experienced by the current carrying conductor. So what is happening over here is that the current's direction is getting reversed. From ABCD, it is going through B, it's D, C, B, and A. So what is the direction of the current? Let's try to map it out. So it goes from the battery to the commutator, to the brush P. From P, it moves into the commutator Y. From the commutator or the split ring, it goes to the armature coil from D, C, B, and A, back to the split ring X, to the commutator Q, back to B. So what is happening over here is that from here, if you look at this, this is the flow of the current. B for that is a battery to the to the brush P to X, A, B, C, D, then Y, Q, and B. Now what has happened? The direction of the current has changed to B, P, that is a battery. The brush is still the same. It is not moving at all, but the split ring from X has become Y, and from A, B, C, D it has turned to D, C, B, A, and X, then Q, and then the battery again. So because of this continuous reversal of current, so now again what happens once the circuit reaches to when the commutator or the armature coil reaches to DC, again it experiences a force. Again the current is passing through this way, the magnetic field is this way, and again it experiences a force downwards. So this continues to rotate as long as the circuit is turned on. This, my friends, is how a simple electric motor works. You see this clearly. You can see that the force is acting downwards when it's in AB. Then what happens? It switches to from AB it goes to CD's position. Then again CD will come back to AB's position, and this keeps on happening. They keep on interchanging their position from AB to CD, from CD to BA. So this keeps on happening until the current is turned on. This is what leads to the working of this is the working of a simple electric motor. Now this rotation, this energy, the mechanical energy that is there, is then used to run the axle. The axle can be then connected to a gear or a simple blade or a fan, and it starts to rotate. As simple as that. So that, my friends, is the working of a simple electric motor. Now let's talk about what are the factors that affects it. Obviously, you can, if you think about a simple fan, you can increase the speed of the fan how much ever you want, and you can also decrease it whenever you want. So what are the factors that determines the rotational speed of a motor, or the rotation of a motor? The first one, you guys already know, increasing the strength of the magnet. That is increasing the number of coil, increasing the strength of the magnet, and increasing the strength of the current as well. All of these are the factors that can increase the rotation of a motor. One is increasing the stronger the permanent magnet is, the stronger the magnetic field is, and thus the more the force experienced by the current carrying conductor as well. You can pass more number of coils through it. So if you ever opened up a DC motor, you can see so many small copper wires in that, and that is the reason is why, because of the fact that when you have more copper wires, it experiences more force, and so the rotation would also be much more faster. Thirdly, increasing the number of coils as well, and by increasing the number of the current through the circuit as well. So from a 5-volt battery, if you connect it to a 15 or 20-volt battery, more current would be passing through it. So what tends to happen is that the rotation would also happen faster. So if you talk about a fan, the reason why it runs much more faster is because when you turn the knob, what happens is that more current is allowed to pass into the motor, and thus the speed at which it rotates would also increase. As simple as that. Or the number of rotation would also increase. As simple as that. Now that you've understood this, guys, let's do some questions. I hope you guys understood this. If there's any doubts, do let me know in the comment section below, and I'll try to answer it. Now let's do the questions. But before we get into the questions, guys, I have an announcement to make, and you guys know about it already. But yes, for all the new guys out there, here it is, guys. It's going to be super important. So listen to me for the next 2 minutes. It's going to be very, very helpful. So here's the thing, guys. We have done a survey about what are the problems that you guys are facing, especially during this pandemic. Related to your studies, obviously. What are the problems that you guys are facing? So the first problem, guys, that majority of you guys are facing is nothing but doubts. Sir, how do I get my doubts cleared? I'm studying from so many different places, but how do I get my doubts cleared? The second problem that majority of you guys are facing is nothing but notes. So how do I get the notes so that I can refer to it later? Third problem that you guys are facing is tests and assignments. So how do I go and give the test without even practicing? So where do I practice myself so that I can become better at whatever I'm doing? Fourthly, competitive exams, because I'm pretty sure that many of you guys are looking forward for your NSOs and ISOs and your KPY and NTSC, so many competitive exams that you guys are practicing for. So how do you practice yourself for that? How do you prepare yourself for that? Choice of your own schedule, that is also another problem, because you're not free when the teacher is free, the teacher is not free when you are free. So that is also a very big problem. And finally, guys, the choice of your own language. How do I study in my own language so that I can understand it better, rather than having to convert it in my brain from English to Hindi or Hindi to English? Here's the thing, guys. At Vedantu, we have solved all these problems. Now, let me just tell you that in doubts, when you talk about doubts, guys, in the class, you'll not just have one teacher. You will have the master teacher as well as the class teacher to help clear your doubts as well. So the class teachers function is to help you clear your doubts. The master teacher would be teaching you and also helping you clear your doubts as well inside the session. You would be able to download all the notes, whatever is written on the board. You can download that and watch the recordings how many of a number of times that you want. There is no limit to it. You can you have regular tests and assignments to check what your progress is, and based on this tests and assignments, you'll also get a detailed report card at the end of the month to check, to really answer the question whether are you good at that concept. Do you really have to spend a little bit more time on that? Apart from that, you'll be trained for your competitive exams. You can choose your own schedule. Whatever time you feel like studying, you can choose that time, and you can choose your own language. Now at Vedantu, we are offering sessions in Hindi as well as in English. Now I'm pretty sure that majority of the country can understand Hindi or English, so the classes are offered in that as well. So here's what you have to do, guys. You have to click on the link that is given in the description to take you to a website which would look like this. So as soon as you go to this website, this is what you're going to get. You have to choose which grade are you in. Let's say that you're in 10th grade. You click on 10th grade, they'll ask you which board are you in, CBSE, ICSE or Maharashtra. Let's say that you're in CBSE board. So you click on that and this is what you're going to get. Now, here's the thing, guys. For now, it is CBSE, ICSE and Maharashtra. In the future, we might be adding more to that as well. But for now, it's CBSE, ICSE and Maharashtra board. So let's say that you click on the CBSE syllabus. You'll get all the information that I just told you right now in a simple glance. You can go through it if you want to. So once you get to this page, what you have to do is click on Get Subscription. Once you click on Get Subscription, they'll ask you what do you want to go with. Do you want to go with the 1 month, 3 month or the 6 month program? Let's say that you want to go with the 1 month subscription course. The base price of that is 4,000 rupees, but you get a primary discount which brings down the price to 2,699 rupees. If you add the coupon code that is AM Pro, if you click on this option called as enter coupon code and enter the coupon code AM Pro, you'll get another additional 500 rupees discount. Essentially what you'll be paying is 2,159 rupees for the whole month. Let's say you want to go for the 3-month course. The base price is 10,000 rupees, but you get a primary discount of 6,999 rupees. That is what you'll be paying before the discount. So if you use the coupon code AM Pro again, you'll get additional 1,399 rupees discount. Essentially what you'll be paying is 5,599 rupees. Now, if you go for the 6-month course, again, the base price is 16,000 rupees. You get a primary discount, which gives you the price down to be, makes the price down to be 11,499 rupees. If you use the coupon code AM Pro, again, you'll get an additional 2,200 rupees discount. Essentially, what you'll be paying is 9,199 rupees. Now, here's the thing, guys. All of that is there in the description below. And trust me, guys, you'll find it really, really helpful. So do check out the link and let me know what you think about it. And do not forget the coupon code AM Pro. Do not forget this coupon code as well. Try it out and let me know what you think about it. With that said, let us now get into the first question for this session. Now, I want all of you guys to let me know what is the answer in the comment section below, A, B, C, or D. You don't have to type out the entire thing. You can just let me know if it is A, B, C, or D, and I'll let you know if it's right or wrong. So here's the question, guys. Which is the static part of the motor that form connection between the split ring and the external circuit? Axle, the coil, the brushes, or the magnet? What is the answer for this question that connects the motor or the split ring and the external circuit? What is the answer, guys? Is it the axle, the coil, the brushes, or the magnet? The answer, guys, is nothing but the brushes. The carbon brushes or the graphite brushes are the ones which connect the split ring and the external circuit. That is the one that acts like the broker. So it connects the outside world to the inside world. Moving on to the second question. How do we find the direction of the motion of the coil? Is it same direction as rotation of motor? Can we use the right hand rule, Fleming's left hand rule, or none of these? What is the way to find out the direction of the motion of the coil? You know the answer for this one. It is none other than the option number C, that is nothing but Fleming's left hand rule. Using the Fleming's left hand rule, you can find out what is the direction of the motion on that particular coil depending on the direction of the current. As simple as that. Next question is, which part causes the direction of current in the coil to reverse after every half rotation? Is it the split ring, the coil, the brushes, or the magnet? What causes the change in direction of the current inside the coil or inside the armature coil? What is the reason for that, or what leads to that? Which part is responsible for that? Split ring, coil, brushes, or the magnet? Comment section. The answer, split ring, people. The split ring is the reason for that, because the split ring is the one which rotates every half rotation. What happens is that from ABCD it becomes CDBA, and thus changing the direction of the current inside the armature coil. As simple as that. The fourth question, guys, here we go. An electric motor is a device which transforms mechanical energy into electrical energy into mechanical energy, kinetic energy into potential energy, or electrical energy into potential energy. I started the entire session off with this one concept. I'm pretty sure that you know the answer. comment section. The answer to this question, guys, is option number B. Without a doubt, it converts electrical energy to mechanical energy. As simple as that. It's a straightforward question. The last question for the day, guys. In changing the speed of a fan, we change the magnetic field, we change the current in the coil, we change the number of turns in the coil, or we do all of the above simultaneously. What is the reason, or what is changing when you change the speed of a fan? When you turn the knob, what exactly is happening? I told you this as well. Comment section. The answer, you're changing the current inside the coil, guys, because you're increasing the current. When you increase the speed, you're increasing the current passing through the coil, and thus what happens is that the fan starts to rotate much more faster. As simple as that. So that is it from my side, guys. Do not leave yet. Your homework. This is the homework for today. Let me know what is the answer in the comment section below. Parts of the motor which do not rotate are called as what? Which are the parts which do not rotate in an electric motor called as? Let me know what is the answer in the comment section below. So that is it from my side, guys. I hope you guys enjoyed today's session. Leave a like, subscribe to the channel, and be notified of whatever sessions we're gonna come up with next. Thank you for joining. See you all in the next one. Take care of yourself. This is Anoop signing off for the day. Have a great day ahead, guys. Bye bye. See you all.